Here's the next theorem, the side angle side similarity theorem. So when two sides are proportional, there's one pair, here's another pair, and the given included angle is congruent. In this case, it's angle Q and angle A, which are congruent to each other. Then we can say that overall those two triangles are similar to each other. We can also say side-side-side similarity theorem. Again, these have to be proportional to each other. We could set up an extended proportion to show that all of these are in fact equivalent ratios. So there they are. We'll just set up our proportion, see whether it's true or not, and then we can say whether these triangles are similar based on the side-side-side similarity theorem. So now let's apply those theorems to several practice problems. Here we're trying to verify whether these triangles are similar or not, so of course we'll use some of those theorems that we've just discussed. So let me set up an extended proportion to see if this will work or not. I'm going to know which corresponding sides to match up together based on whichever one's the smallest in the triangle, whichever one's the middle length in the triangle, and then whichever is the longest. So 6 is to 9, those are my two short sides. Now if I pick off the middle lengths in the triangles, I'll say 8 is to 9. Sorry, let me erase that. 8 is to 12. That's the middle length. And then the last one would be 10 is to 15. So now we need to simplify these ratios to see whether they are in fact the same. And if you divide the first one by 3, you'll end up with 2/3. If you divide the second one by 4, you'll end up with 2/3. And if you divide the third one by 5, you will also end up with 2/3. So therefore, we would say yes, they are in fact similar by the side-side-side similarity postulate. Now we'll look here at B. We're going to focus on these two sides, K, M, that side here, and also KN over here. So if I look at KL and say KL must be proportional to KM, that length there would be 8 is to 10, because if I do 8 plus 2, I end up with that 10. And then now if I do the same thing down on that bottom line, KP is to KN, I have 12 is to 15. Now these two fractions, do they reduce? If I divide this first one by 2, I end up with 4/5. If I divide the second one by 3, I end up with 4/5 also. So therefore, I have two sides that are proportional to each other. Now I need to focus on either a third side or I need to focus on the angle. Now if I look here at this angle, angle K is in both the smaller triangle and the larger triangle. So really, angle K, and this seems like an obvious statement to say, but I can say that angle K is congruent to angle K. So therefore, I can say the side angle side postulate.